So we're going to be designing an app store today, like the Google Play Store or like the one for Apple, which is just called the App Store. For similar problems, we're going to be handling and processing large files, which is the executable. So good examples of large file processing pipelines are Dropbox or Google Drive or YouTube. I haven't covered this problem yet, but I know there's a lot of coverage on it out there, and so it should have a lot of overlap. These are some other ones that also do some stuff with an object store, I think. Actually, I'm not sure on coding competition platform. Well, okay, I think you save your old copies of your code submissions, and that might be a large file. I forget exactly how I did that one. Web crawler definitely had an object store as well. There's going to be a celebrity distribution of access to the large files. So, for example, the really popular apps like Instagram or TikTok. So that's going to make this a little bit more different. YouTube does also have a celebrity issue. I guess that one would also probably be a good example for that. But I don't know if you'd really use a CDN for, you might do something a little bit different with YouTube, but that would make it a little bit weirder. But we're going to have a celebrity distribution, and it is actually going to have a really big impact. I did actually crunch some numbers beforehand. So I actually did the numbers. I haven't done that in a couple of months. What is that called? NALSD, non-abstract large-scale design. And I also added a little component in the library for a load balancer. I've been neglecting that so long, and I finally realized why. It's because I don't have a load balancer standard component that I can just click on and add to the diagrams. Now I've got that. We can maybe remember to use that today. Anyways, moving on to requirements. The users will be able to download an app. You'll be able to upload an app. The app will be scanned for malware. So there'll be a little chunk of processing pipeline there. I wanted to kind of like clump in the malware scanner problem with this one. That was another one that I've been asked to do for a while back. And I was like, you know what, I think I can kill two birds with one stone here. And so we'll go ahead and clump that in here. I should maybe cover that one separately as well, though, just because the NALSD for that would, of course, be pretty interesting. And then apps can have updates. So that's another that I think that's usually covered as a separate problem as well, is usually you'll have like an app store as a problem, just like the download and upload. But then another really popular problem for interview questions is pushing updates to millions of devices around the world, like updating an operating system. I think it's usually kind of like updating the Android OS or Windows for devices around the world, pushing that out. But when you update an app like Facebook or Instagram, there's of course millions or even billions of users. So that would have a very similar kind of approach to it. I'm going to try and tackle that as well today. So we have quite a fair number of features. This might be a pretty long video. Any questions about the requirements or the resources I've provided before we try and get into some other aspects of this? All right, I'll keep going then. So like I said, I did actually crunch the numbers. I haven't done that in a couple of months. It's not something that people, it seems like I usually get a huge video drop off in retention whenever I do it. And that's why I've been leaving off so much. But it's really interesting in this case. And I just crunched it beforehand to make this section a little bit faster. And then it's probably a little bit easier to follow along with. So I looked at for downloads and the update portion on just how much bandwidth you're going to need in both cases. So I recently saw an article about how ChatGPT is now has like the newest record for hitting 100 million users in the shortest amount of time. Before that, it was TikTok. ChatGPT doesn't have an app, if I recall correctly, while TikTok is primarily used as an app. And so I think that would probably be a better This would be the biggest celebrity on an app store currently. And it hit that 100 million mark in 9 months. I'm going to be seeing what kind of bandwidth you need for downloading an app 100 million times within 9 months. And I have the size right there. And then I also did the numbers for updates. So I'm assuming that the daily active users will all get updated within 1 week. I didn't look at the monthly active users because I was like, well, you know, if they're only using the app once a month, would it really be reasonable that they're going to go ahead and they might try and like avoid the app update or something? While with daily active users, it's more reasonable that like they're going to get forced to do the update within a week. So I looked at daily active users and I was like, let's assume that it gets pushed out within 1 week. And the download numbers were not very impressive. So that's why I also crunched it for the updates, and the updates got a much more impressive number there. So for the download pace, 100 million users in 9 months came out to about 300,000 users per day. That is 3 to 4 seconds, 3 to 4 users per second. It's a 340 megabyte file. That comes out to about 1 gigabyte per second. Why do I still have this here? Okay, so that comes out to 1 gigabyte per second. You might be able to handle that off of one Ethernet cable. That might be pushing it, particularly since there's traffic variation. But I'd imagine that like you might be replicating this around the world. So like TikTok probably has at least one bucket somewhere in the US, another bucket somewhere in Asia, another one somewhere in Europe, etc. So it's probably not really going to be pushing it for the Ethernet cable's physical limits if you're when you consider how it's probably going to get replicated around the world. So download pace was really not that impressive. Update pace is where it got a lot more interesting. We had 1 billion daily active users for Instagram. We're assuming that they all get an update within a week whenever it's updated. There are 700,000 seconds in a week. So I wanted to figure out how many users would be updated per second. So that is 1,300 million users in 0.7 seconds. So that's just billions converted to millions. And then this converted to over here. So 1,300 million divided by 0.7 came out to 1857. So that is an update being performed about 1,800 times per second. And it's a file size of 240 megabytes for the whole app. So you get about 400 gigabytes downloaded per second. That's a lot more impressive than 1 gigabyte per second. So you're maybe going to need something a bit more than an object store, probably a CDN at that point. It's apparently I should specify whether it's push-based or pull-based, and I'd imagine a push-based CDN. You push it, and then immediately anybody that's downloading it would start receiving the new version, and then you can have a separate thing that is handling the like sending it out to the existing users over time. Any questions before we keep going into the diagram? Any questions about the numbers or requirements so far? All right. I will keep going then. Yeah, okay. Yeah, so I like to start with the entry points and exit points. The update part is a little bit less well baked for my research that I did into this, since I did so many features on. I tried to do so many features at once. So we need to start with our entry points and our exit points. So we're going to have client uploading an app, client app upload. We're going to want the app download as well. Yeah, that'll do. And we're also going to have, yeah, so it's like the client phone. This is like your phone. So we'll say user phone. And then this one is developer uploading an app. And then we're also going to have user phone for app update. There we go. We got all of our entry points and exit points, and we're not going to be done until all of these are connected. So I want to start with the app upload. So you're going to need a backend service, and you're going to need an object store. And it's going to be a multi-part upload. Anytime that your file is bigger than a couple of kilobytes, you should maybe consider it. But if it's bigger than, I think the cutoff is about 65 kilobytes is the size of the packet of death, at which point, if you try to upload something bigger than that, it'll actually choke out some routers that were made in the 90s. And you just, so these files are like hundreds of megabytes. You can't send that in one thing. So you're going to need to do a multi-part upload. So we're going to have a backend service. So you first do, this will be the upload service. You're not actually going to send the file through the upload service. You're going to send it to the raw app object store. It's just going to be something like an S3 bucket. So the first thing you do, you hit up the upload service. It is going to send back it's going to tell you a S3 bucket location for you to upload to, and then you're going to go ahead and you're going to upload it to that object store. And then when you're done putting it at that location, you are going to send an ACK to the upload service to let it know that it is done uploading, and then it can go ahead and do some stuff downstream to send it off further on the pipeline. So we're also going to need a metadata store. Whenever you have an object store, you're probably also going to want to have a metadata store. So we have a raw app metadata store. So it's also going to be chatting to the raw app metadata store. And I got that load balancer component. I don't think we really need one at this point. I didn't crunch the numbers, but I can't imagine that you're really going to be having uploads occur. I think we can keep this linearizable. So there's like hundreds of thousands of apps, I think. How often are you really going to be pushing a new version of an app? Maybe once a week or something, and then it's a lot of those apps are probably dead. I don't know if you really need a UUID. I think you can go ahead and keep this linearizable in some way. For YouTube, for their metadata store, I'm pretty sure they did PostgreSQL and they used something called Vitess, VITESS. So we're probably going to end up having something like PostgreSQL manually sharded could work similarly. See, I told you this was relevant to this problem. I'm just going to steal how YouTube does their metadata store for designing the app store for our design. And so since we have that, I'm pretty sure we can keep this linearizable, and you can just do like something that looks relatively like this instead of having to do a whole UUID like Twitter. I'm pretty sure this should work. And then what other stuff? Oh, you're going to need the S3 bucket location. So it would be the S3 URL. So you're going to have something that looks like s3-aws.amazon.com/some bucket/object location. Yeah, and then we're going to want to have a status on there as well. Status uploaded initially, scanned. There could be a couple of different scans. You could actually, okay, so you could probably do concurrent scans. Maybe there's like different types of scanners for different types of malware issues. So you could even have, let's say that we have, I'll make 3. We'll have scanner workers for it's we'll call it for A, for B, for C, And it's for just different ways that different types of malware, different things that you would check for in the upload that would be malicious or that you just don't want to have there. So we'll have those. We're going to run them against the object store. And I guess we're going to have an orchestrator that coordinates this. Yeah, we could coordinate this with an orchestrator. So I'm going to have something like AWS step functions for orchestrating it. Orchestration. Sure. All right. I'll just have it run over like that. And we can do CDC to get it to the next step with a DB trigger. That should work fine. An alternative is to have a message broker attached to the upload service, but then you could have, the partial failure scenarios for that would maybe be a little bit interesting. And this one just seems a little bit more straightforward for those partial failure scenarios. Okay, so it's going to do this. It'll do one step at a time. It'll do, what do I want? An arrow. Okay, and so kick off that first step. And then this one's going to pull down the binary and it's going to scan it. And then when it's done, you'll get a response back. And then the orchestrator will go ahead and update that flag. And you can go ahead and have, I said that you could maybe do this concurrently for the steps. I haven't actually had a ton of hands-on experience with AWS step functions, but I'm pretty sure you can run a couple of steps in parallel. There should definitely be some way to do that. Yeah, okay. So we would have like status for scanning A. So it would be pending, success or fail. And then you can go ahead and have the flag for B and C. Otherwise, you would have you can't have it in just one because then you'd like want to scan it like in serial. And so like if you had B complete first, that would make it confusing. And so you'd maybe actually want to split some of the scanning statuses like that. And then I guess you could still have an overall status that could maybe help simplify things for like when all three hit success, could then go ahead and flip it over to the scanned step. So then that's a little bit denormalized, but it's totally fine to do that. NoSQL databases are fully denormalized. So yeah, I think it's okay to have a little bit of duplication there. And then, so for all three, kick off a step, have it go ahead and tell the scanner to go pull in that file and scan it like that. It sends the response back. And it updates that status there. And then when all of them are done, I guess we can go ahead and kick it over to a next step. It could be uploading it. Let's go ahead and move the download over to here to try and keep it a little bit more simple. So I think you could maybe just keep it in the same place, just keep the raw app in that object store, or, well, okay. I mean, you would want to have copies of the object store in each region. Like Asia, Europe, and North America. And it wouldn't really be necessary to replicate it until you're done scanning it. The scanning thing, I mean, you could get all the raw app copies to one specific data center or something. It doesn't, you don't have to have your scanning necessarily globally distributed. That would maybe have unnecessary complexity to it. So you could maybe have a step where we're copying it to the globally replicated object stores, or alternatively a CDN for the ones that are maybe popular enough. Well, so for the regular download rate, even for like TikTok, it was like maybe 1 GB per second. I don't know if you necessarily need a CDN there, but you're definitely going to need one for when you're doing the updates. And that would probably be the same, like it would come from the same place as like downloading. Updating and downloading should come from the same storage, I'd imagine. Unless for the update, you could possibly use a CDN, and then when it's done pushing it out to the majority of users, you could go ahead and let the TTL on the file expire for the CDN or something. And then they would switch over to the object store for finding the app. Yeah, this one's a little interesting. Yeah, I'm curious whether you would necessarily have the updates treated differently than the downloads for the apps. I'm just going to go ahead and use a CDN here, but that is an alternative approach, is to maybe have updates and downloads treated differently. Let's go ahead and mark this now. CDN for app download. Okay, so they'll have to locate your app off of some kind of metadata. I mean, I guess this metadata store could be the same one, I think, that the users have for searching for apps. And then you would just have leader follower replication, because the users aren't really going to be doing a write when they're doing the searching aspect. So you could go ahead and have, I did something in proximity service where I had this like thing that was listening over CDC, and then if it was a certain type of event, it would go ahead and fan it out to a bunch of replicas downstream. So you would have some follower replicas. So it's follower metadata store. So you'll have some replicas over here. How it gets over there, whether you want to do it direct though, I'll saying that you might be able to just have something subscribed to, like these aren't going to care about tracking the scanning status. You don't need to do a write to all the metadata stores for that. So you could have, I didn't mark this one either, CDC with DB triggers. And then we would similarly have another thing. We could have a task runner that is listening. This would be replication task runners. So it would also listen over CDC for the events that it's interested in, and then when it hits the scan status, you can go ahead and copy it over to the followers. Okay, so they're going to hit these for search, we'll say. And we'll keep it like that. And then the user is going to, they're going to find the app that they want. This wasn't really in the scope of what I was particularly interested in this problem, so that's why I'm kind of doing some hand waving over here. You'd also need to have, of course, a backend service and a load balancer over there for the search scenario, I'd imagine. Totally hand waving over here. But then when they get to the actual app download, they have the location of the thing. You would want to do, okay, I mentioned that I should have some kind of copy or worker that gets the stuff from the app object store over to the CDN. We're going to need that. We can get to that in a second. I guess I'm going to get to this download part first. So you can actually go ahead. So it will get the S3 location. You'll also have a CDN location. That's how they're going to know the location of that CDN in the object store, though, is that they're able to pull it off over through here. So there's an optional CDN location. CDN URL, yes, / what is it? Cloudflare.com/my object, and that's an optional attribute. And then they can just go ahead and do a read straight off of this, either there, or they would do it from here. And you can go ahead and read directly off of an S3 bucket. You actually are able to do that. You can even host an entire static website directly off of an S3 bucket. So although normally your client is not going to be able to interact directly with a database, like if it's a SQL database or like DynamoDB or something, you are actually able to do that with an object store like S3. And you don't want to send that massive file over through a backend service. It's going to have a bandwidth bottleneck. So you do want to have it go directly through the object store like that. Let's go ahead and have the copier workers. I'm going to have something that will go ahead and push it into the CDN when it is, so when it hits that scan status, we're going to want to have something that copies it into the CDN and also globally replicates it for our users to download. So we're going to need these copiers. And I think we can have the AWS step function talk to, yeah, it'll be something similar to that. Let's move these down a little bit. Oh no, okay, that looks really messy. I'm really tempted to clean this up a little bit. I don't know if I will. Yeah. All right, I'm gonna cave. I'm gonna go ahead and clean this up a little. Sorry, guys. Let's take that too. Take it like that. Yeah, those scanners. And then we have this. It'll be a worker kicked off by a step function. I don't think you would normally have step functions are kind of like Lambda functions. Lambdas have a timeout for how long you can run a task. So I don't think you can actually really use them like a worker. A worker is something that I associate with like a long running task. And you would think that AWS step functions would be totally ideal for that, just having these like random jobs to kick off, but I'm pretty sure they actually have a timeout. And so you might actually need to have something that's more of like a worker, and you can't actually use AWS Lambda functions for that. And I'm pretty sure AWS step functions would similarly have some kind of timeout that would not allow you to use them directly for the copier workers. That's what these are, copier workers. They are globally distributing the object after this thing flips over to scanned. And this would be the one that writes that scan status over here. So you don't need to go through CDC. It's totally fair to just have it straight off the orchestrator. In fact, that would be a little bit better because a lot of the scope is probably going to be owned within one team. And so it's choreography is more of a thing where it's like a naturally arising pipeline where there's steps added that you don't pre-plan out at the outset of designing your whole product. While with orchestration, it's like, you're going to have a couple of these like steps to your pipeline, and they're all owned by like one team that knows they have to like create this like series of steps. And so orchestration's more ideal for that. It allows you to not have like a crap load of brokers all over the place. So it's gonna update that status to scanned, and then it'll say like, hey, go ahead and start globally distributing it. So then it'll tell this thing to do that. It'll pull in the raw app object and then copy it to places all around the world. If it's a super hot app like TikTok, it might stick it over there. I mean, when you're doing an update, you're similarly going to want to do that scan for malicious stuff, because I mean, you could have a perfectly fine app and then just slip in the malware down the road. So I mean, the updates would similarly go through this whole pipeline, and then you put it on the CDN, or you put it in the same place. I mean, I guess you could just go ahead and stick a TTL on there for and keep it the same for both download case and the update case, so that you don't have like two fully separate pipelines, and you would just have a TTL of like a month or something. And then that would handle the really hot updates for an app when you push out an update for like Instagram or something. Okay, so we have the copier workers, we got this download case, we got the scanners. We can admire our work for a second. This would pull it in and then push it. That's what's going on with this arrow. I'll draw what's going on with this arrow is that you pull the record and then you like write it to all three of those, just like this. I haven't actually seen details of it working exactly like this in the real world, but just intuitively to me, it seems like a thing that would be done. Yeah. Because alternatively, you can just have it set up directly with leader follower. Instead of having to like go all the way through a task runner to set up leader follower for you. So that's two different approaches here. I can maybe specify that in the text file. For metadata replication, two approaches, one task runner replication only under relevant CDC events. That's currently shown. And then two, alternatively use built in leader follower replication and just replicate all updates to all the followers. Okay. Updates, right? Updates. Okay, so you don't want to slap all 1 million users with the update at once. Oh, you know what? We should check for any questions before that. Are there any questions before we try to move on to handling the updates? Cool. All right. Yeah, we'll move on to the updates. So you don't want to slap them like all 1 million users with an update at once. In fact, you'd probably even want to. I don't know if it really supports A/B style stuff for apps. You would usually build in some kind of A/B rollout of a feature through a lot of apps I think currently use like React Native or something, and then you would be able to have like I think like the A/B release of features would normally be through this thing that doesn't require the App Store to do the A/B stuff for you. I've published an app myself, and I definitely don't recall anything that allows an A/B style rollout of a new app thing to all my users that was like available anywhere in my publishing features. So and then but like from the standpoint of like Google or Apple, when somebody does an update, it's going to be super hot if you go ahead and like, oh, there's also two approaches for the updates. It's either push style or pull style. So push is when the server pushes out a notification and says like, okay, it's time for you to update your stuff. And then there's pull style, which is where the device does like a daily check for whether or not it should update anything. So I think I'm kind of going towards the push style approach where the server like tells, you might have all your devices registered somewhere, and then you would tell them like, okay, you're up. You can go ahead and pull it from the CDN now. So I think we're going to need to have some kind of user metadata store. It'd be, well, I think it would be OLAP. You'd probably have the user data store. You'd have like an OLAP copy of it that you would you'd have like a batch of users that you'd have selected every hour or something, and you should you could fan out a bunch of updates to selected groups of users every hour or something. You could also monitor the load against the, well, okay, CDN could be managed by like Cloudflare. I don't know if the App Store or Google Play like roll their own content delivery network for the App Store specifically. I'd imagine not. I'd imagine the App Stores don't roll their own CDN. So then they wouldn't be able to monitor the load on the CDN. But we saw with LeetCode over the last few weeks that LeetCode even manages to overload their CDN during the competitions. So I feel like the App Store would similarly be able to very easily overload the CDN. So it does seem like we would need to make sure that we're not overloading the CDN. We do need to do this batching thing. We can't just let the CDN monitor the load on its own, because we can overload it like LeetCode has been doing. Okay, so we have this. We're gonna have some workers or task runners or something that are going to select some batch of users that they're going to fan it, and they're going to, you would have that group, you'd stick it on this broker, and you'd send it off to a notification service. And then it would tell the users, hey, it's time to do the upload. How do I want to do this? Oh, okay. No. I have a special component like that. I like to make it orange. There we go. And so we'll have it's a notification service. So it could be something like SNS. Okay, and SQS, SNS is like a common pattern. And it like probably handles some integration for you. Otherwise, it's you might have like a task runner as a Lambda trigger off of the broker, and then it would push it to the notification service. Let's go ahead and maybe draw that. We could maybe draw that. This would be fan out workers. And then we would have, you need Lambda triggers that are listening to the broker. So you need to do a pull off of it and turn it into a push to the notification service possibly. Then you've got your notification service. And then you would tell, so your phone app update, they'd receive your push notification, and then they would know to go ahead and pull it off of the CDN. And so the upload half of the update is going to be going through the exact same path as an initial upload of your app. So this was like written for like an initial creation of your app or something, and you can just go through the same exact route for updates. You'll do the scanning and all that, and it'll go through this exact same thing, stick a TDL on the CDN of like a month. And then if it's so then for like update, it'll of course be really hot for Instagram. And then after a while, if you're only doing like a release every few months or something, it'll cool down after a month. It won't be pushing so hard to a bunch of users. It should have like an exponential decay to the update rate from your users actually doing something about it. And then do we need to track the status of whether the users have actually updated or not, and like use that to figure out whether or not to fan out to them? That's what I'm trying to think over right now. So when you're doing these fan out workers over here, I think you can go ahead and have it, you just make sure that you cover all the users uniquely. You don't re-hit the users. You would select a bunch of users, maybe update their status on the OLAP table as sent or not, and then whether or not they actually perform the update, whether or not they clicked like, yep, do it. I think that status can just go ahead and be handled directly on the device. And then, if they put it off, well, that's okay. I mean, you don't necessarily need to track that. It should still follow an exponential decay. So we don't need to monitor on the server side whether or not they've actually updated it in order to try and balance the load on the CDN. It should just naturally also follow that exponential decay. Okay. Any questions on what I've got on this? Oh, I moved that over there. Okay, I don't see any questions, and I'm pretty happy with what we got. I did have a couple of other approaches, but we've already got a fairly decently length video with a pretty fair amount of complexity covered, so I don't want to cover them in this. I think you guys could probably figure them out on your own. So thanks for joining. I appreciate it. Hope this was interesting to you guys. Thanks a ton for watching. I will see you next time. Thanks. See ya.